Okay, this question says you are given the following function, g of x, which is equal to the square root of 4 plus 5x. We want to find a derivative of the function using the definition of a derivative. So let's write down the definition of the derivative. We have g prime of x, which is equal to the limit as h approaches 0 of g of x plus h minus g of x divided by h. So now let's go ahead and plug in our function into this definition. So we know the input is x plus h. So the first part here is the square root of 4 plus 5 times x plus h. And then we're going to subtract the function, the square root of 4 plus 5x, and then we're going to divide that by h. Okay, so what we want to be able to do is we want to take a look at this function and say, is there something that we can do to manipulate it so that we no longer have just h in the denominator? So what we want to do is multiply that numerator or rationalize the numerator by its conjugate. So we're going to multiply the numerator by the square root of 4 plus 5 times x plus h plus the square root of 4 plus 5x. And then we're going to multiply the denominator by the same thing. So we have the square root of 4 plus 5 times x plus h plus the square root of 4 plus 5x. Okay, now what we notice in the numerator is that when we multiply these two together, the conjugate tells us that we end up getting difference of squares when we multiply them. So that means we square the first term and then subtract the square of the second term. So when we square the first term, we have the square root of 4 plus 5 plus, 4 plus 5 times x plus h, and we square that term, and then minus, we square the next term, which is the square root of 4 plus 5x. Again, we notice that when we square a radical that has a root of 2, that means now we're left with 4 plus 5 times x plus h minus, in parentheses, we have 4 plus 5x since it removes the radical there. Now let's distribute the 5. We get 4 plus 5x plus 5h minus 4 minus 5x. So we end up eliminating the 4, we end up eliminating the 5x, and what we have left in the numerator is 5h. So now we're going to write our limit as h approaches 0. What's left in the numerator is 5h, and what we have in the denominator is h times the square root of 4 plus 5 times x plus h plus the square root of 4 plus 5x. Now what we notice is that we can now simplify that h, and what's left in the numerator is 5. So we have the limit as h approaches 0 of 5 divided by the square root of 4 plus, distribute the 5x plus 5h plus the square root of 4 plus 5x. Okay, now we're going to evaluate the limit as to when h is 0. So we're left with 5 in the numerator. And since h is 0, this 5 times 0 is going to give us 0. So in our denominator, the first term is the square root of 4 plus 5x, plus the second term, which is the square root of 4 plus 5x. And now since there's two of them, we can combine like terms. So we end up getting 5 over 2 times the square root of 4 plus 5x. Or we can write this as 5 divided by 2 in the numerator divided by the square root of 4 plus 5x. And therefore that's going to represent the derivative of that function. Okay, the next part to the question is they want us to find a domain of the function. So the original function is g of x, which is equal to the square root of 4 plus 5x. Now remember, inside the radical, okay, you can include any number that starts from 0 and on. You can't apply any negative number, so you can't take the square root of a negative number. Therefore, in order to find the domain of this function, we're going to take 4 plus 5x, and then we're going to set that to be greater than or equal to 0. If we subtract 4 to both sides, we get 5x, which is greater than or equal to negative 4, and therefore x has to be greater than or equal to negative 4/5. So if we want to write this in interval notation, just recall that on our number line, we have negative 4/5. So that means we have a bracket and it's going towards positive infinity. So therefore the domain of this function is bracket negative 4/5 to positive infinity. Next, we want to be able to state the domain of its derivative. So the derivative function was 5 over 2 divided by the square root of 4 plus 5x. Well, notice that now this is in a denominator. So because it's in a denominator, it cannot be equal to 0. So it's going to be slightly different than what we did in the previous step. That means we're going to take this and take 5 or 4 plus 5x, and then that's greater than 0. Solving for x, we subtract 4, and now x can be greater than negative 4/5. So again, on the number line, we know that if this is where negative 4/5 is located, we cannot include it, so we have a parenthesis going to positive infinity. So therefore the domain is negative 4/5 to positive infinity.